Hello and welcome to another video. In this video we're going to be working on the intersection of two arrays 2. And in this you're given two arrays, nums1 and nums2, return an array of their intersection. Each element must appear as many times as it does in both, and you can return the result in any order. And so let's take a look. So in this first example, a 2 appears twice in both of these, so we return 2 and 2. And then in the second example, we have 4, 9, 5 appearing once, so we just take one of each. So there's kind of two main ways to do this. You can't do like a set intersection because you can have duplicates, but there's kind of two main ways. One is sorting, and two is counting. So let's go through both of those. So I guess we can go through sorting first, and then we'll go through counting, and then we'll code up one of them, because the coding part isn't super hard. So basically, actually, let's go through counting first. So let's do like a little clever count. So one thing you can do for a count is just basically have a count. So for like nums1, we can have a count. So like 1 appears twice, 2 appears twice, and 2 appears twice. So you can basically just make a hash map for each, and then go through the keys of one of them. Let's say we pick 1, and we just say like, okay, let's get the value for this number, and let's see if it exists in the other one. If it does exist in the other one, we'll take the minimum of the two values. So like if there's 2 1s here and there's 5 1s here or something, we'll just use 2. Same thing for 2. So that's how you do it. So we'd say like, okay, 1 appears twice here. Does it appear here? No. So we can skip. 2 appears twice here. It appears here twice as well. So we can write down 2 twice. And we can do the same thing for the second example. So we can say like 4 appears once, 5 appears once, 9 appears once. And then here we can do 4 appears twice, 9 appears twice, 8 appears once. And then we can just go through all the keys in one. So we could say like, okay, 4 appears once. How many does it appear here twice? We'll take the smaller of the two numbers, so which is just 1, so we'll have 1, 4. Then 5, it appears once here and none here, so we don't need it. And then 9, it appears once here and none, twice here, so we'll take the minimum. So we just go through one of the keys and then get the value in the second hash map and take the smaller value of the two. So that's how you do counting with two dictionaries. But you can actually just use one dictionary, and this will help with the follow-ups, and then we can go over those. So basically what you can do, instead of having accounts for both, we can just have a count for one of them. So for example, let's go through the second example. We can just have like a 4, 5, and a 9. And we don't need to return the result in a sorted order. We can return the result whatever we want. So now we can just go through the second array, and for every element, we can just check, is it in this counts? And if it's in this counts, we will decrease the count, and we will write it into our result. So let's go through that. So for example, we're going to go through this 9. We're going to say, is it in here? Yes, it is. So we can add that to our result. And now we will decrease this count. And then we check, is the 4 in here? Yes, it is. So we'll add it to our result. Decrease the count. Is 9 in this? No, it's not. And then you can say like when the count's 0, just delete it from your hash map. So essentially these get deleted. So now 9 is not in here, 8 is not in here, 4 is not in here. And this is your result array. And what you can do here is you can just store a count of the array that's smaller. So like this one maybe. And then you can go through the second one and check, are those elements in here? Because you're going to have to go through both arrays anyway, but you can just have the count of the small array, which will, on average give you a better space complexity. Obviously, like, the big array can have like every single element be the same and so on, but yeah. So that's what you can do with the counts. You can just use one hash map and then go through the other one. Now sorting is also pretty straightforward. So let's go through the sorting example for example 2. So essentially you just sort. And so if this first one is sorted, we have 4, 9, 5. And the second one will be 4, 4, 8, 9, 9. And then all you have to do is just, so let's actually move these down here. And let's do this. Then we just need a pointer for each of them, like this. And then we just check. There's basically 3 cases. This is not sorted, so 4, 5, 9. So there's three cases. The elements are the same, in which case you just write it to the result. So in this case, they are the same, so you just write a 4 in the result. And if they're the same, then you can just move both pointers up. If one is smaller than the other, like if 4 is less than 5 here, we know there can't be any more 4s here because it's sorted, right? So we'll just take the smaller element and then increase it. So we'll just go here. Now 5 is less than 8, so we'll increase this way. Now 8 is less than 9, so we'll increase this way. Now they're the same, so we can write out a 9 in here and then move them both up. And then when one's out of bounds, we're done. So essentially you just take the smaller element and you move it up one. If they're the same, you move them both up and you write the element. And that's how you do sorting. So let's go through this, because this would be like the kind of thing you would be asked in an interview. And this is where you can take like an easy to medium LeetCode and actually have good follow-ups, and then the people that just like memorize solutions aren't going to do well. So for this one, if their array is already sorted, obviously it's pretty straightforward. You would just use this algorithm, right? A 0 space solution. If nums1 size is small compared to nums2, which algorithm is better? So in this case, we'd want to use the counting, and then we would just count nums1, and then go through nums2 and check are those elements in nums1. Every time one element is in there, we'll decrement nums1. That way our memory will be nums1 size, and you can't have a better solution than like nums1 plus nums2 time, right? You have to go through both arrays no matter what you do. So you can't have lower time complexity than this. So essentially, that's what you would do. If one is like significantly smaller than another, you would just count the smaller one. And if nums2s are stored on a disk and the memory is limited, that you cannot load all the elements in the memory at once. So basically they're saying here, I guess, nums1, you can do whatever you want, but nums2 is like kind of big and you can't load the whole thing. So in that case, we can just go with approach 1, and we can just take nums1, turn it into a hash map, and then we can just process chunks of nums2 and then check like are those elements in there, right? Because we don't need to load up the whole nums2 in memory. We can just load up a little bit, check which ones of those are in the hash map for nums1, and then write those in the result. Load up the next bit, load up the next bit, load up the next, whatever. And obviously we can't do, in order to sort, you have to like load the whole thing. So you can't do that. I mean, I guess you can like do some weird sort where you like where you sort like chunks, but that wouldn't be super good. So the best thing would be approach 1. You use a hash map for nums1 and then process nums2 in chunks, which is fine. Okay, so let's just code up one of these. I guess we can code up let's just code up the hash map. So what we're gonna do first is we're just gonna say we're gonna get a hash map of the smaller array. So let's just say if nums1 is longer than nums2, we'll call this on the reverse. So if nums1 length is longer than nums2 length, let's just flip the variables. Okay, so now we're guaranteed that nums1 is shorter, so then let's just do the hash map for nums1. So we could say, map integer counts. Okay, and then for every number nums1, we can increase the counts. So I think there's like you can use getter default, but I think there's something better. Let's see. Compute if absent. That might be the thing. I don't remember for sure. Put if absent. That also might be fine. I guess we could do this. Yeah, this is fine. So we could say counts put if absent. So if that key is not in there, we'll just put in 0. And this is going to be num. Then we'll say counts dot set, or put, I guess, counts dot get, counts dot put. So it's going to be the key. So right, num counts dot get. There's probably like, maybe there's a better way to doing this. Actually, no, I don't like this that much. I think let's just go with this. Yeah, just use the getter default. Maybe that's better. Okay, so num 0 plus 1. That definitely looks cleaner. Okay, so essentially get the value if it's there. If it's not there, put it in a 0 and then add 1. Okay. Now we'll have a result array. We don't know how long it is, though. Yeah, so if we don't know how long it is, we probably need to make it a link or a list. And then we need to, then we'll convert it into an array, I guess is what we're going to do. So we'll say like list integer. And this will be like result. Because we don't know off the bat like how long our result is going to be, right? It is kind of weird that they use an array here because you don't know like how long the intersection is, but whatever. Okay, so then we're going to go through all the numbers in nums2 now. And then we're going to say if counts dot contains this number, then we'll add it to the result. And we will decrement it in counts. So put num, so if it's in there, we'll just get num -1. And if it's 0, then we'll delete it. Get num, then we will delete key or something. Let's see, clear, not clear. Remove. Okay. So now basically the last part is we need to return this thing converted to an array. I think there's like a 2 array. From object to int. Oh, because this will be an array of integer. Okay, I don't know off the top of my head, so I think we'll just make a new array. So this will be result size or length or something. Let's see. Size, length. Oh, this isn't res. This is This shouldn't be res. It's gonna be like, oh, I guess not the best. Whatever. Size. Okay. So now we will just manually put them in. So we'll say, yeah. Probably a better way to do this, but it's fine. Size. I think this is like an at or something. Get. Don't know if it's that one. All right, let's try get. And then I think this will be like the index. All right. Definitely could be written cleaner, but get the idea. Okay, nice. Yeah, so this one, obviously, this memory-wise isn't going to be as good as like this, what's it called? The sorting, but it's still fine. And yeah, probably better, cleaner ways to do this, but this works. And yeah, this should be just linear. Or n plus m, yeah, like I said. You can't have less than going through both arrays. And then the space will be just the length of this first one should be. Min, yep, exactly. That is what we wanted. Okay, so like I said, time is n plus m, and space min and m, because we're basically just making a hash map of the one that's smaller. So that's why all these follow-ups of like if the bigger one is on disk or whatever, you could use this and it would work pretty well. So yeah, kind of in depth. Hopefully this is helpful. Definitely like a little bit overkill for an easy problem, but it isn't an easy problem, so I didn't just want to make like a 4-minute video. And you can use this for harder problems. And like I said, I think actually interviews with these follow-ups are pretty good because you can ask easy questions and then just have good follow-ups and then make sure people are actually thinking instead of memorizing solutions. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.